have two missions, which is on one hand, provide business support to scientist entrepreneurs. To give you an idea, in 2024, we supported about 300 startups through one of the programs of the DeepTech Center globally, so really across all continents. And the flip side of that is actually to re-inject the learning of science and technology into the curriculum for non-scientific students. So we believe that business students or anyone with a non-technical background should still get the fundamental of science and technology if they want to be, reasonably good decision makers.
Thank you.
Hello, everyone. I'm Anne McKenna. For the purposes of this conversation, I have one head and three hats. So I am the founding director of the Africa-Oxford Initiative at the University of Oxford. I'm a biochemist by background, and so the work of Africa-Oxford is to bring collaborations between Oxford University and a range of African institutions. I am also supporting global partnership at the University of Global Health Equity in Rwanda, and so I work at the ends of academic world, and with my business hat on, I am the co-founder and CEO of Research Alpha, which is an AI-driven platform that connects academic research expertise with industry needs. I'm delighted to be here.
Delighted to have you. Thank you, Anne.
Hi, everyone. My name is Durojai Phillips. I am the founder at Innovia Labs. Innovia Labs is an R&D and prototyping outfit in Lagos specifically for hardware and deep tech solutions. So we started in R&D and prototyping, and then we started a venture studio so that we can actually innovate in-house and also bring in new companies, help them build their prototype and de-risk their solutions, and then get them into the market. So that's what we do at Innovia Labs. And also I run Titan Air Mobility. I know a lot of people have heard of Joby, Archer, and all the, in quote, flying cars around. Yeah, but in the industry, we don't call them flying cars. We call them eVTOLs, electric vertical takeoff and landing aircrafts. So I run Titan Air Mobility. We build eVTOLs, we build ecosystems, and we build vertiports. So the goal is to make sure that in Africa we are well connected, as in using aerial mobility to connect everywhere within Africa.
Thank you and welcome to our panelists. Let me get started with a question that can get us hopefully in the right frame of mind. And maybe we'll start with you, Noel. The first question I wanted to ask is about the trends you see today that are reshaping the innovation landscape in deep tech, especially in Africa, and then we can go from there.
Parfait. Alors les tendances de deep tech, je vais m'appuyer sur le modèle Masser. On va dire Masser, on a toujours été focus sur une R&D orientée marché, orientée industrie. Alors le choix s'est porté à l'origine, donc en 2007, sur 3 grands pôles technologiques, à savoir la biotech, qu'elle soit végétale ou médicale, matériaux avancés et enfin tout ce qui est microélectronique. Et donc, si je prends par exemple la biotech, aujourd'hui, ça fait partie des tendances. Si je vais un peu plus dans le détail de la biotech végétale, à Masser, pendant 10 ans, nous avons une équipe qui a travaillé et qui est montée en compétence dans tout ce qui est microalgues marines, de la culture, la valorisation et les différentes applications. Et aujourd'hui, on a une algothèque, une bibliothèque de souches de microalgues, de 200 souches qui sont répertoriées, qui sont caractérisées et qui fit pour des applications particulières. Donc si je prends le domaine de l'agriculture, et c'est là où c'est intéressant parce que ça intéresse également d'autres pays africains, nous avons développé des biofertilisants et des biostimulants issus des microalgues marines qui vont venir renforcer le système naturel de défense et de croissance de la plante tout en préservant son environnement. Ces biofertilisants et biostimulants sont exempts de produits chimiques et ils ne sont pas concurrents aux engrais phosphatés, ils en sont des compléments. Alors, comme on est dans une logique de valoriser justement la R&D, et depuis toujours, depuis ces 15 dernières années, donc une fois que le projet était mature, nous avons créé une start-up qui s'appelle Tecalga et qui aujourd'hui produit et commercialise ce type de produits justement, qui ont donné des résultats juste exceptionnels en matière de rendement sur différentes cultures. Donc ça, c'est pour le domaine de la biotech végétale. Dans le domaine de la biotech médicale, c'est tout aussi intéressant. Nous avons une équipe qui a travaillé dès 2009 sur la mise au point de kits de diagnostic moléculaire pour des maladies prévalentes au Maroc et en Afrique. Juste pour information, pour ceux qui ne le savent pas, l'ensemble des kits de diagnostic moléculaire, toutes technologies confondues, qui sont utilisées au Maroc, que ce soit dans les CHU, dans les cliniques privées, dans les labos privés, sont importés. Alors, ils sont importés des États-Unis, d'Europe, mais également récemment de Chine, de Corée du Sud, et j'en passe. Et donc, cette même équipe de biotech médicale a travaillé, comme je vous dis, pendant une dizaine d'années pour développer une expertise. Et en 2016, on a été capable de développer des kits pour diagnostiquer la leucémie, l'hépatite C, basés sur la technologie PCR en temps réel. Et donc, on était prêts, quand le Covid est arrivé en 2020, l'équipe, on les a challengés, et l'équipe a été capable de développer un kit en l'espace de 3 semaines seulement. Non pas qu'ils étaient des génies, mais parce que justement il y avait tout un investissement en temps, en formation, etc. Et nous avons pu valider ce kit à l'Institut Pasteur de Paris, en France, et par la suite on a pu l'enregistrer au niveau du ministère de la Santé. Et on a levé des fonds et on a pu produire pendant les 2 années de pandémie, on a produit quasi 5 millions de tests, de quoi couvrir l'ensemble du réseau du ministère de la Santé marocain, mais également, et c'est là où c'est intéressant, on a effectué des opérations d'export en Afrique pour plusieurs pays en Afrique à travers le CDC africain. Alors, ce qui est intéressant, c'est qu'une fois que cette brique technologique est maîtrisée, c'est facile après de la décliner à d'autres virus, d'autres pathologies, qu'elles soient infectieuses, cancéreuses. En août dernier, on a vécu une expérience intéressante pour le Mpox, la variole du singe, qui a sévi en Afrique. Et pour ce virus, en l'occurrence, on a pu, pareil, développer un kit. Donc, on est quand même réactif aujourd'hui. Et on a pu développer ce kit rapidement. On a pu envoyer l'équipe à Kinshasa, à l'Institut national de recherche biologique, qui avait des échantillons pour pouvoir tester et valider le kit. Et donc, ce même kit a été donc, autorisé par validé par les autorités sanitaires africaines. Alors, l'IA, parce qu'on revient à l'IA. L'IA nous a permis, en matière de dépistage et de diagnostic, d'aller plus vite. C'est-à-dire aujourd'hui, Masser étant un centre de R&D pluridisciplinaire, on pousse les équipes à travailler ensemble. Et typiquement, en matière de diagnostic, on a une équipe donc de biotech médicale qui a développé un réactif pour la TB, pour la tuberculose. C'est quand même une maladie qui continue à sévir et il y a quand même 30 000 nouveaux cas chaque année au Maroc. Donc, cette équipe a développé le réactif chimique. L'équipe de microélectronique a développé un dispositif électronique qui va simuler un bain-marie et qui va permettre de diagnostiquer la tuberculose en 20 minutes à la place au lieu des méthodes classiques qui prennent plusieurs jours. Et c'est là où l'intelligence artificielle, justement, parce que c'est un dispositif où il y a de l'IA qui est embarqué, permet d'aller plus vite dans le diagnostic. On l'a expérimenté également pour le Covid. Pour le Covid-19, grâce à la technologie de spectroscopie proche infrarouge avec de l'intelligence embarquée, on a réussi à dépister, donc c'est du screening de premier niveau du Covid-19. Donc on va venir dire si le patient est négatif grâce à l'IA et en 20 secondes seulement. Donc si on revient aux tendances, donc la biotech, évidemment, biotech médicale végétale, tout ce qui est spectroscopie proche infrarouge avec de l'intelligence artificielle qui nous a permis à Masser de développer des capteurs d'analyse en temps réel sans utilisation de réactifs. C'est tout l'intérêt. Et donc, on est dans une logique où ce n'est plus l'échantillon, par exemple, si je parle de l'agriculture, ce n'est plus l'échantillon qui se déplace vers le laboratoire, mais l'inverse. On est dans des dispositifs, des capteurs portatifs, connectés, qui vous donnent le résultat de manière instantanée sur smartphone et qui va venir typiquement pour les agriculteurs les éclairer et pour qu'ils puissent, enfin, ça leur donne des recommandations pour qu'ils puissent prendre des décisions rapides et efficaces.
I think it's very impressive to see the examples of an idea that goes through research and then goes into commercialization and scale outside even, Maser. So maybe for you, Amrik, what can we share with the audience in terms of how can organizations, public sector, private sector, businesses, collaborate effectively to build an ecosystem that supports the scaling of deep tech research here in Africa from your perspective?
So first of all, I strongly agree with that. Ecosystem is the key word for deep tech innovation. I like to think about deep tech innovation with two frameworks. The first one is as a science funnel, and the second one is as system engineering. The first one, a science funnel, is, I think, critically important in the sense that even in deep tech entrepreneurship, the important part is not entrepreneurship, it's science. Meaning that you need a full stack science ecosystem that goes from, student at university up to, inshallah, successful deep tech unicorns. And that means that you need a funnel that works efficiently and especially that minimizes waste. Meaning that you don't want failed deep tech entrepreneurs to be kicked out of the system. You want everyone to keep on contributing. Meaning that as a student, you can contribute to the success of existing startups, you can build your own project, you can try, you can fail. If you fail, you can try again or decide that your place is in academia and find your way back inside. So really this idea of a science funnel, which is really focusing on making sure we get all of the sources of science, whether it's from university, academia, public research organization, corporate R&D, and we take it from everywhere, and we have this funnel that works in a very integrated fashion, and everyone who steps into one of the branches can step into the other one. So that's the first one, saying like, all of the science is a focus, and if that science produces successful companies, that's a plus. And the second one is, from a system engineering standpoint, I think nobody will be surprised by the fact that deep tech is complicated, meaning that it's a very complex system. And if we want successful deep tech companies, we need a lot of things to go right. So we need actual, good science in the lab, we need efficient technology transfer, we need efficient funding mechanism, we need good business incubators, we need good infrastructure, good platform. So it's a really, really complex system, and so that means that the system needs to be designed like a system engineer would, mean like all of the parts has to be designed in relationship to each other. And I think that's one of the key aspects where all of the African ecosystem have a very, very strong opportunity, which is in a younger ecosystem, you can actually do the co-design of the different parts, making sure that your university works from scratch by design with the incubators, with the VCs, with the CVCs, and that everyone is both co-created, co-designed from scratch with this collaboration in mind, and is co-evolving, meaning that each program, each component of the system is still being kept aware of what's happening, saying, oh, actually, if investors are changing their thesis, maybe we need to build a new program as an incubator. As a university, maybe we'll create a new track, a new master degree where our students will be able to work. And as long as all of the components keep on co-evolving, I think this is really the only recipe that works for a strong deep tech ecosystem.
It is definitely a complex recipe. Maybe, Max, let's take a step back a bit, and we do understand this is complex to have all elements of the system to go right for deep tech to succeed. But maybe we can go back and say why this is important or fundamental for Africa. So maybe you could address the question of why deep tech is critical for Africa by Africans.
Merci Amine. Effectivement, la deep tech, souvent, on l'associe à des enjeux qui sont très importants, on en pourra en parler après avec des exemples, très précis comme l'a fait Nawal. Mais on a du mal à associer la Deep Tech et l'Afrique comme l'Afrique un moteur de la Deep Tech. Et j'ai vraiment la conviction, et pour moi c'est même limite une évidence, que l'Afrique devient et est déjà un vrai moteur de la Deep Tech. Et justement, je vais m'expliquer. La Deep Tech, on ne l'a pas encore définie ici, mais la Deep Tech, en quelques mots, c'est l'ensemble des innovations technologiques, souvent qu'on qualifie de rupture, et qui requièrent des temps longs de développement, d'où la nécessité d'un écosystème, comme l'a dit Émeric. Et pourquoi? Parce que la Deep Tech apporte des innovations, des nouvelles solutions technologiques à des besoins qui, justement, ne trouvent pas des solutions simples ou l'assemblage de solutions simples avec les technologies existantes. Donc ça prend des temps longs. Revenons à l'Afrique, ou par rapport même au monde entier. Tout le monde entier doit faire face aux transitions en cours, au dérèglement climatique, transition énergétique, à la question de la biodiversité, et encore j'en passe. Mais pour l'Afrique, c'est une réalité d'aujourd'hui, voire depuis de nombreuses années. Donc s'il y a un continent qui appelle, non pas demain, mais qui appelle aujourd'hui des solutions viables qui vont au-delà des solutions actuelles pour résoudre les défis globaux, c'est le continent africain. Donc l'Afrique est vraiment le lieu où cette innovation Deep Tech doit prendre forme. Donc Deep Tech et Afrique est vraiment une évidence. Et l'Afrique, moteur de la Deep Tech, est vraiment une évidence. La deuxième question derrière ça, c'est la Deep Tech par l'Afrique. Comment est-ce que l'Afrique devient vraiment un moteur de la Deep Tech? Je repars sur l'aspect Deep Tech. La Deep Tech apporte des nouvelles innovations technologiques qui prennent du temps, qui prennent des temps longs. Pourquoi ça prend des temps longs? Parce que justement, c'est des défis, des problèmes qui sont complexes, qui ne trouvent pas de solution simple. Et par rapport à ces défis complexes, souvent, c'est interdépendant d'un écosystème, au sens de l'environnement, et donc de variables locales. Donc si une technologie est développée ailleurs, peu importe dans le monde, et importée telle qu'elle, usée telle qu'elle, et n'a pas pris en compte dès la conception la spécificité locale des géographies africaines, il y a très forte chance que, la technologie voit sa performance réellement dégradée, voire qu'elle soit totalement inutilisable sur le terrain. Il faut vraiment, dès la conception, dès le développement, travailler avec les acteurs africains, quelle que soit la géographie, pour prendre en compte la variabilité locale. Et donc on va aller encore un peu plus loin. Qui de mieux que les acteurs africains pour connaître leurs besoins, pour qualifier réellement ces besoins et pour trouver les solutions utilisables sur le terrain. Donc vraiment, Deep Tech et Afrique est une évidence, et Deep Tech par l'Afrique est une nécessité et une réalité aujourd'hui.
I like the idea of Africa as the engine of deep tech innovation. And I think as you talk about systems engineering and engines, I'm thinking about who drives that, and that's basically the individual. So maybe Anne, and I know you are in between Europe and Africa, so you have the global perspective, you have the local African perspective. What are the contributions or the role that the African R&D researcher can bring to the global scale and vice versa, from the global perspective into the needs of Africa? Because I think, you know, every engine needs a conductor, and that's basically the human talent.
Thank you for that. And I am going to piggyback on some of the comments that my colleagues have already mentioned. The way we define deep tech really is about intensity in the 3 T's, right? The high intensity in time, in talent, and in treasure, right? So treasure being the money. So let's start with the simple one, money, right? If you look at how research and development is funded across the world, in the UK, about 50 to 60%. In fact, in the UK, about 73% of our R&D costs come from the private sector. In China, in most developing nations in Asia, you're looking at 70 to 80% of the R&D costs are coming out of the private sector. In Africa, we are still about 30 to 35% coming from the private sector, and from actual local investors, maybe less than 20%. So as we look at who's funding, who's driving this, whoever puts the money normally calls the shorts, right? So how do we unlock local investors in the continent to actually invest in R&D ecosystems that will power the deep tech innovation? That's, I think, a big challenge. And alongside that as well is thinking about what do we fund and how do we de-risk it enough to be able to unlock that local capital? Because, you know, the pension funds are not going to release money into some voodoo thing that they cannot make any sense of. Right? A good part of it is actually educating investors in the continent about what deep tech is, what value it creates for them, and what they get out of it. And as scientists, we are not necessarily very good at articulating that value proposition. So that's the one unique challenge and opportunity for private sector to play a role in the African R&D. The second layer of that is, of course, talent. It's been mentioned a few times here about the importance of the highly skilled talent that we need to drive the deep tech innovation ecosystem we want to see in the continent. Now, I don't think that's a uniquely African problem. I think recently at the European Innovation Summit, very similar to this, they said, you know, in 2022 that we need to train 1 million deep tech skills. And you know what they did? They went out and did it, right? So in the same way, over the last 3 years, they've worked with about 600 universities, research institutions, saying, how do we leverage what we already are doing very well at to direct that training into skills that we actually need in the here and now? I think last year's summit was brilliant in that it laid out the foundation of the deep tech ecosystem in Africa. I think this summit, our mandate is to go beyond there and think about the capabilities that we have within our research and university ecosystems to be able to see who's got what to do what, and therefore leverage that for collaboration. I think we can make it through coordination, coherence, and collaboration. And finally, very quickly, I think it's worth mentioning the issue of time. Right? We've heard, of course, that it takes a long time to develop these solutions, and we've heard from Nawal as well that AI is really transforming the R&D timelines, really crunching it to much shorter timelines than before. The one thing that we haven't been able to address well is the time it takes to actually get lab reagents into African research institutions. Right? I can use AI to reduce the amount of time I need to identify drug molecules, but how do I get the pipettes in the lab to do the lab work? It takes about 6 months to a year longer for an African research university to actually order for equipment to be able to start doing the work. And in some cases, because we don't have access to the manufacturers, it can be up to 100% more in cost. And then you layer that, the ports and everything else. So what I'm trying to communicate is that we do need to optimize for our time, our talent, and for our treasure. And that will have to come from Africa's itself, coordinating and having coherence within our R&D ecosystem.
The moment you said scientists aren't necessarily good at presenting their ideas, I thought of Emmerich's pivot in his career, went to culinary school. Exactly. Maybe that was his MBA, or to go to a culinary school to learn a little bit of presentation. And
I think that's what we all need to do.
It's probably, maybe let's go back to somebody who's trying to make it through. And the question that came through the interaction earlier, I think the funding models, policy frameworks are very critical to the success of an idea, to a commercial construct in a company. How can these funding models and policy frameworks be adapted to support and accelerate deep tech initiatives and ventures in the continent?
Okay. So, funding models and policy. I like how you put it, the time, treasure, and what's the last one? And talent. As it is, yeah, if you were to innovate today, let's say you are building a hardware solution, if you are doing a hardware solution, you are doing a hardware solution, and I am doing a hardware solution, we all have to buy the same equipment. So now, why are the three of us buying the same equipment when we could as well have gone to a lab and the equipment is available and the three of us can go to the lab and build our solutions from there? So how we can get there is that we need to think of galvanizing local laboratories. It could be hardware lab, it could be a cluster of processors for AI training, it could be a biotech lab, it could be an agri lab, so that you can safely and quickly experiment cheaply. So now that is where the talent is reducing the amount of treasure that is needed to actually come up with these kind of solutions. And then you're also reducing time because you are not importing the machines from Europe or from America. That will take you at least 6 months to 1 year for them to take your order, make the machine for you, and ship it down. Then you go and bother with customs that, hey, I want to clear this thing, and they are billing you crazily. So that is one model that we know can readily increase the amount of research done, the amount of R&Ds that is being done, the amount of startups that are coming out of Africa. We know that can increase that. So on the policy level, depending on how the policy is being drafted, these policies need to cater for the creation of all these labs. Whether it's going to be government established labs or the government is working with funding private laboratories to be created, or private organizations are creating these labs to solve their own problem first, because private organizations, they can do CSR, but they are not that kind. So they can solve their own problem first, and then the labs are also open to the public to create new solutions. So now in deepening how AI is going to help us be better, we need to create these kind of clusters. I met one Mr. Johnson while we were networking. He's creating data centers, AI-enabled data centers. Those are critical so that we can start creating our own AI models. And there is this utopian future that is in my head. I think is going to come to pass very, very soon in the next 5 years. Why we need to be able to talk and have instant translation in our local dialect. Yes. In Nigeria, we have about, I think about 200 unique tribes, and with their own unique variation of their languages. We need to be able to have conversations. And this is a uniquely African thing, that across different countries, you have different tribes, different languages, like it's very, very diverse. We need to be able to use our own local resources, our own DeepTech stack, our own AI stack, our own large learning models to be able to solve these problems, and then we can now be able to communicate better. And once AI is helping us do that, we can have a lot more prosperity within Africa.
I think the example that you gave around dialects and languages resonates with me. Whether it's Morocco, whether it's Nigeria, or the entire continent. I think a continent level or a national level natural language model is just an obvious opportunity for everybody in the audience to lead. And we do have the tools available to build large language models that focus on natural language that can bring to life all the richness of the different dialects and languages we have across the continent. So, and it doesn't require a lot of physical lab infrastructure, so it's still a digital infrastructure heavy effort. But I think what you said reminds me of what happened in 2006 with the advent of cloud computing, where many innovators didn't need to procure digital infrastructure anymore. They could rent it and build digitally native, multinational, global conglomerates. I don't know how to do it on the physical space when it comes to physical medical labs, hospitals, things to do material science to blow things up. But I think it's the same business model. You want to centralize the heavy lifting of procuring physical infrastructure so the scientists can focus on the novice ideas. And I think it's a complex problem to solve, but it's one that we need to solve in the way that you described.
Yes. So in essence here, what you just described is exactly what needs to be done. Apparently, that means the deep tech industry, where we're creating chips and lots of microprocessors, eventually gave birth to the digital space that we have today, such that as an innovator, you just buy AWS and you don't need to worry about setting up your own server. I think with the way we are seeing it, at the end of the day, deep tech is the core background for every single innovation that needs to happen, and we need to start early.
Yeah. I have a lot of thoughts, but I'm going to go back to questions. I don't want to be a participant. But let's go back to, I have a second set of questions, and we can go through those quickly. I think private and public partnership plays a key role. You've talked a little bit about the funding models. Commercialization is where we need to be heading, and it requires a lot of parties to play nice, to collaborate, to make that happen. So maybe, Emric, Noel, from your perspective, having been in 2 institutions that have done that, what is the role of this partnership, and how, give us examples of how these partnerships make commercialization feasible of deep tech research?
So first of all, yes, they're absolutely essential. I think what's important is to go back to the essence of a startup. The only job of a startup is to de-risk. This is why you exist. If it was not risky, it would not be a startup, and you would not need VC capital. You would just go happily to a bank, and it would be very easy to predict. So since the job is to de-risk, this is where I think it's really important when we get economists and social science in the loop. And to echo what both Anne and Philippe you said, it becomes a matter of resource optimization. And so meaning that your job as a CEO is to make arbitration between resource expenditure. And when we get into public-private partnerships, this is a way to leverage existing infrastructure. And I think infrastructure is probably going to be one of the words which is repeated a lot during those 2 days, because this is really the backbone of everything we do. And so the simple fact that we are able to optimize and to leverage existing resources, existing infrastructure, wherever they come from, has a strong impact on the de-risking and on the time management and runway management of a venture. So that's one of the really starting points, de-risking through resource optimization. And the second one is, it's customer money is always way better than any type of investment. And this is where the complexity is, which at whatever the system, you always have a lot of inertia. I mean, public spending has a lot of momentum, corporate as well. And so we really see the only successes there when there is absolutely massive sponsorship from the top of whatever institution is behind. I mean, I guess UM6P is a great example of what the power of strong leadership from the top can bring. We see same when a government or a big corporation is involved there. So that's the only key success factor I think we can witness, is getting that leadership that can trickle down and impact the system level change.
Excellent. Anything to add, Noel, quickly?
Je reviens à ce que disait Anne par rapport à la part du secteur privé dans l'investissement de la R&D. Tu parlais de pourcentages qui font rêver ici au Maroc, 70%, 80%. Alors au Maroc, malheureusement, la culture de l'innovation, et ça il faut le dire, culture de l'innovation, de la recherche et développement n'est pas encore suffisamment développée. Bon, pour ma part, ça fait 16 ans que je suis dans ce domaine, et l'industriel marocain n'a pas encore compris que c'est crucial, et qu'aujourd'hui, soit tu innoves, soit tu meurs. Il y a ça d'une part. On manque également comment dirais-je, on manque cruellement de financement public. Hein, aujourd'hui, c'est des initiatives isolées, mais il n'y a pas encore, en tout cas jusqu'à il y a quelques semaines, il n'y avait pas encore une vraie stratégie de financement de la R&D. Alors, tout récemment, il y a quand même un gros budget qui a été débloqué de 1 milliard de dirhams. C'est une première dans l'histoire de la R&D au Maroc, et c'est moitié financé par le ministère de l'Enseignement supérieur et l'autre moitié par cet écosystème, donc OCP, UM6P. Les partenariats publics-privés peuvent être très importants pour faciliter justement cette commercialisation. Parce qu'aujourd'hui, ok, c'est bien d'avoir des idées intéressantes, d'être dans de la deep tech, mais le tout, c'est d'avoir un marché. Et donc, c'est cette première commande qui est importante. Et aujourd'hui, ce type de partenariat, enfin, ces PPP peuvent aider. Et je reviens sur l'exemple de Masser. En plein Covid, on a pu lever une somme d'argent d'un fonds de solidarité Covid, voilà, qui nous a permis très rapidement d'installer une ligne de production, justement. On a acheté les équipements qu'il fallait et on s'est transformé de chercheurs bio-ingénieurs en biotech médicale en producteurs de kits de diagnostic. Et ça a été possible grâce justement à ce PPP. Tout récemment, pareil, on est en train, en tout cas c'est en cours, de nouer un PPP entre l'UM6P, le ministère de la Santé marocain et l'Institut Pasteur pour que désormais tous les kits de diagnostic qui sont importés et qui existent au Maroc, en tout cas qui ont été développés par nos équipes, eh ben, soient fournis, et ça va nous permettre de substituer aux importations qui se font jusque-là.
Oui, et je me permets d'apporter un autre point complémentaire sur ces enjeux-là, de vraiment l'importance de ces partenariats publics-privés. C'est par rapport aux chercheurs, en l'occurrence publics, qui développent une innovation technologique. Il y a deux choses. Dans le deep tech, il y a les technologies qui sont révolutionnaires, et les médias en parlent beaucoup. C'est l'arrivée de l'IA il y a quelques années, bientôt les technologies quantiques qui vont arriver. Mais la très grande majorité des innovations qui utilisent ces révolutions, c'est pour répondre à des besoins réels d'aujourd'hui, comme j'ai dit tout à l'heure. Et pour ça, il faut se rapprocher des besoins. Ça veut dire qu'un chercheur qui développe dans son coin une innovation qu'il pense être extrêmement utile pour un usager, qui ne l'a même pas questionné sur est-ce que vraiment tu en as besoin, dans quelles conditions et avec quelle performance, ça n'a pas de sens. Et donc le partenariat public-privé permet de se rapprocher de l'usager quand c'est un usage industriel, et surtout d'avoir accès à la donnée. La donnée industrielle peut alimenter de manière extrêmement vertueuse tous les modèles de recherche et la génération, notamment par l'IA, de toutes les innovations qui en sortent. Donc c'est à la fois des moyens, c'est à la fois de la gestion de partenariats, mais c'est aussi de répondre réellement aux vrais besoins qui est visé.
So it's a good point. I would like to move into success stories. The private sector is incentivized by return on investment. So maybe we could, if we can share a couple of success stories of deep tech idea that moved into commercialization and it's been successful, because that's probably what the ingredients missing to really incentivize, especially the private sector, to say, I can make 100x, 10x. It will be 10, 15 years out, but a return could be extremely, extremely rewarding. So maybe some examples from Anne or Philips, Emmerich.
I'm very happy to share a few, and I really resonate with what the other speakers have mentioned. I think just to really circle back on that question of facilities to be able to do this research, it's very possible. I mean, the model that the UK has taken, for instance, is all these wonderful innovations are happening. I mean, we have about 590 startups that come out of our universities, but about 100 of them just came from Oxford alone. Right? And then between Oxford, Cambridge, and Imperial, almost 70 to 80% of them. And I don't think Africa should follow that model. I think it's too high of a risk. I think because of our geopolitics, sometimes we like each other, sometimes we don't. I don't think that's a real opportunity for us. I think what we could be thinking about is a distributed R&D facility where we can leverage what you've got in UM6P. Somebody else is building a drug discovery center in UCT, in in Cape Town, somebody else is building something else in Institute Pasteur. Let's leverage what other people's capabilities are and grow together rather than doing those concentrated ways that Europe and the US has gone. Now, to share a couple of examples, I mean, Hutano Diagnostics is a company that we're involved with it's a Zimbabwean innovator who's developed, you know, when a young child comes into a hospital, she's got multiple reasons why she has a fever, but we can't always tell, is it a bacterial infection, is it a viral infection, do we need to treat it for sepsis and so forth. So it's developed a really beautiful aptamer-based rapid diagnostic test where you can be able to use 20 different biomarkers to identify what it is that causes the fever, and therefore you can treat it in the right way. It's developed for Africa. There's multiple others I can show for sickle cell anemia that we funded through the Africa Oxford programs. But my biggest concern with this is that we build really wonderful innovations. We invest a lot in the de-risking the science and the product engineering, but immediately we get to the exit point, guess what happened? Like with Hutano Diagnostics, it was bought by a Cambridge company. So the benefits immediately leave after we've done all the labor. So it's like carrying a baby to full term and then somebody comes and snatches it when you're ready for them to help you out. So as we think about how we invest in that whole first set of, you know, skills and talent and research to be able to build a deep tech ecosystem, let's also think about what's the eventual outcome? What's the exit strategy? We don't have a lot of vibrant stock markets to IPO. I mean, InstaDeep is amazing, but it's an outlier, as it were, right? So what is the actual exit strategy for all these startups? Or are we building for somebody else to reap the benefits?
It's, I think an exit strategy for every startup, folks I've talked to here, is being acquired, going to IPO, and I think being acquired is more feasible than going to IPO, and we need to make sure we have a pathway to successful, scalable companies beyond IPO, not just being acquired by a bigger fish.
A ready example is InstaDeep. InstaDeep is an amazing company, and it's...
I don't know if the audience know, but if you could share more about the company.
InstaDeep is more or less an AI company. And the reason why there are not a lot of InstaDeeps in the world or in Africa today is because we've in the past neglected this investment in deep tech. In fact, I think we here right now, we are practically one of the pioneers, let me say, because 10 years ago, if you said you were in deep tech, someone would look at you like, we don't know what you're doing. But now it's becoming a lot more fancy. So I think everyone should give themselves a round of applause for that, because for there to be a deep tech summit means that the ecosystem is actually growing. Now, concerning what you said about distributed infrastructure, I totally agree with that. We do not need to localize every single thing in one place. If we can do biotech better in South Africa, then biotech companies should cluster in South Africa. If we can do synthesis of new medicine better in Kenya, we can do it in Kenya. And if we have abundance of electricity in any country, because there's a lot of sun, yes, we can locate servers there so that we can run a lot of AI models from there. So yes, I totally agree with that in terms of how this can be deployed and how different nations can see what best works for them and how they can take advantage of that unique position they have in the deep tech industry.
I have one last question to ask, and I think it's related to what you said. A lot of what I'm hearing you saying, it hints towards how digital AI just has a lot more or shorter time span to value and commercialization. So maybe I'll have someone at least end with what the future holds. I think everybody seems to agree that AI to be part of deep tech. AI here to be an accelerator. where do we see that intersection, let's say in the next 5 to 10 years? Maybe I can have you, Max, and someone else, just give us a prognostics of what we see in the future of that intersection.
La question est évidemment très compliquée, il faut faire des paris par rapport à ça. Mais évidemment, l'IA et la DeepTech sont extrêmement liés, ne serait-ce que parce que ce qu'est l'IA. Et je pense que la DeepTech peut beaucoup apporter à l'IA, et l'IA va déjà et apporte déjà beaucoup à la DeepTech. L'IA, si on n'a pas beaucoup parlé ici, mais l'IA, c'est avant tout une approche algorithmique qui, pour la plupart, se nourrit de données. Et en fait, pour construire une IA, il faut plusieurs choses. Il faut de l'infrastructure, puissance de stockage de données, puissance de calcul et de la donnée de qualité. Ensuite, il faut des talents pour pouvoir mener ces choses-là. Et enfin, il faut des écosystèmes qui le permettent. Ce que je n'ai pas dit également dans la phrase, c'est la connectivité, qui est extrêmement importante. En fait, la DeepTech apporte et construit déjà des solutions pour aller plus loin dans tous ces domaines-là. La connectivité, comment connecter toutes les géographies africaines. Là, depuis le début, même moi, j'ai beaucoup utilisé le mot Afrique, mais c'est vraiment des géographies africaines qui ont toujours des spécificités locales. Et comment connecter ces géographies? Première étape. Deuxième étape, l'IA va de plus en plus vers des agents autonomes et des écosystèmes d'agents qui interagissent entre eux pour faire des actions autonomes. Et pour ça, ça peut être de la connectivité entre agents, qui soient déportés ou non déportés, vers où on va. Et enfin, la puissance de calcul. Lorsqu'on a beaucoup de données qui sont de qualité pertinente, on en aura de plus et encore plus. Il faut pouvoir calculer rapidement pour adapter rapidement la force et la performance des IA. Par exemple, les calculs quantiques qui arriveront possiblement dans 10 ou 15 ans, on verra. L'autre avantage, c'est pourquoi l'IA apporte à la DeepTech. Comme l'a très bien dit Nawal au début, la DeepTech, donc la recherche en général, c'est prendre un défi, un objet d'étude, faire des hypothèses, faire des itérations expérimentales de modélisation pour confirmer l'hypothèse, acquérir la connaissance et aller plus loin. Et en fait, l'IA, à travers une certaine autonomie pour générer des hypothèses, pour exécuter des tâches d'itération et comprendre la validation de l'hypothèse, peut vraiment accélérer de plus en plus le cycle. Et on va commencer à avoir des agents autonomes, des écosystèmes autonomes qui vont eux-mêmes itérer ces hypothèses-là pour aller encore plus loin. Donc pour ça, évidemment, c'est, je pense, pas plus que dans 1 ou 2 ans que ça va être mis à l'échelle dans certains laboratoires. Et après, à voir comment ça va influer sur 10 ans. Je vais donner la parole à mes collègues pour compléter.
Music to my ears. Anybody can predict, and then we'll hold your name to that prediction.
I'm not going to pretend that I can see the future.
Okay.
But because of the rapid change of the technology, things are very uncertain and very unpredictable, which is very exciting, a space to be in. But the one thing that will remain true, no matter what technology comes in, is that we need this to be people-centered. It needs to start with people. It needs to be centered around people's needs. It needs to be centered around African priorities. The one thing that I hope when we meet here next year, we will completely have changed is the fact that only 11% of deep tech founders in Africa have PhDs. Globally, that's about 50 to 60%. So I hope we can all commit to the Africa 100 agenda. And next year, we come here and we have at least 20% more.
Excellent.
The next thing I hope we can all commit to is that 90% of those founders are men.
Correct.
So the next meeting we meet here, I can't predict 10 years, but next year when we meet here, let's have raised that number to at least 20%, and then the year after, at least 50%.
Amen.
If we can all commit to that, I think we can move at pace.
I'm going to be yelled at, but I do want to get everybody's interaction, especially this is what I do every day, and at least to hear from deep tech researchers how the integration of the two, I'm very, very interested in, selfishly. So even if they yell at me, I would like to hear from all of you.
Pardon. So seeing the future, we are seeing quantum computing come in the fray.
Correct. That's right.
We have already seen how AI can be disruptive. We are now putting AI into bodies, which are robots, and we have embodied AIs, which Elon Musk is pushing, Figure AI is pushing. Now we are adding quantum computing into the fray. In a figurative sense, we are putting, in quotes, a god in a bottle. Now we need to rethink how we need to approach the problems that we need to solve, because you have almost an infinite solution to humankind's problem in a bottle, practically in your app on your phone. So now, I think I'm imploring us to rethink how we are approaching the problems that we are solving, how it is right now, considering what AI is doing and what we are doing with robotics. What is going to come next is quantum computing, how quantum computing adds to that fray, and we now build for that future, so we are not obsolete in the next 5 years.
Alors, par rapport à cette idée de futur et d'imaginer comment sera le futur, moi je pense, on le voit, la DeepTech, c'est chronophage, c'est budgétivore, il faut être patient, il faut avoir les reins solides pour financer. Mais je pense qu'au-delà de ça, il faut qu'on soit dans une logique où, quand on se projette en Afrique, il faut que le citoyen africain fasse confiance à son concitoyen africain. Il faut qu'on arrête aujourd'hui d'avoir ce réflexe rapide et naturel de recourir, enfin, d'importer des solutions innovantes, toutes prêtes, et de venir les adapter à son pays d'origine. Il faut au contraire recourir à de la R&D locale. On parlait de talents, eh bien, investissons dans nos talents, construisons un savoir et un savoir-faire qui va nous permettre justement d'aller plus loin dans la scalabilité industrielle et surtout de renforcer, ce qui est très important aujourd'hui, cette sécurité sanitaire, alimentaire, énergétique, plus globalement technologique dont on parle, et de renforcer cette souveraineté continentale. Je ne parle même pas du Maroc, aujourd'hui on parle vraiment de l'Afrique.
So
Voilà.
maybe this is, thank you Noel, I think you give me the right segue to end the panel discussion here, and to end it on notes that really combines everything we've talked about. Adopting a builder mindset in the continent. We have our own unique perspectives on the problem that we face in the continent. We have a unique perspective of the global challenges, and we need to have a builder mindset to solve them our way. And the path forward is to invest in deep tech ventures and initiatives, in science and technology. AI is here to be an enabler. It's a disruptor, but at the core of it is an enabler to traditional methods of doing R&D, and we should adopt that. But I think if I have to leave everybody here, let's build for our continent. Let's solve our own problems. Let's leverage technology and ideas from around the world, but let's build unique solutions for ourselves here. I would like to thank everyone. I know you've traveled from around the world. Thank you for being here with us. Thank you for your perspectives to the audience. And hopefully we get to see you next year and continue to see your contribution to the space. And I would like to also thank the audience for stepping forward, and we will have time with the panelists to interact with for the next 10 minutes, hopefully after we. So one round of applause for the audience and for the panelists. And hopefully we'll look forward to the conversation with everyone in the next day and a half. Thank you so much, everybody.